Charles Swanson, who is a licensed irrigator, an extension program specialist on landscape irrigation with the Texas A&M AgriLife Extension Service, and he's going to be talking to us about some landscape water conservation programs that are in place, particularly Water My Yard, which we've had in place here in Denton and Collin County since about 2015. And also talking about some of these smart irrigation technologies that are available to help better manage our outdoor watering, to be more precise in our watering and not to waste water through overwatering and things like that. So with that, well, and I will say that if you have questions for Charles, go ahead and you can put those in the chat box, and we will try to get to those at the end. But otherwise, Charles, take it away.
All right. Thanks again. Thanks for having me, Blake. Glad to be here today. I'm going to turn off my camera here for a second so I get a better view here. But thanks you for having me. Today I'd like to talk about water conservation in the landscape and how we can look at irrigation technologies and programs to be tools to help us manage our landscapes during the heat of summer like we have right now. So just a quick overview of what I'm going to talk about here today. I'm going to talk about different types of irrigation technologies we have available. I'm going to give you some resources to help you identify efficient technologies in the marketplace. And we have a smart irrigation laboratory that I run on campus at Texas A&M in College Station. And so I'm going to talk about some of these products that we've been evaluating in our laboratory, just give you a snapshot of some of their performance to give you some guidance when you go to pick out or if you're considering implementing one of these products. And then I'm going to end the program talking about the Water My Yard program, which Blake has already introduced you to. Okay, so the state of irrigation technology today. We can take existing landscape irrigation technologies and divide it into one of two categories. We have what we refer to as irrigation control technology. This manages when and how much irrigation occurs. And then we have irrigation application of technologies, which manage how we actually apply irrigation to the landscape. Okay, so what are we talking about when we talk about control versus application technology? Well, control technology is obviously going to be irrigation controllers. And so today we have smart controllers that are widely available. And these can be weather or what we call ET based. ET stands for evapotranspiration based smart controllers, or we can have soil moisture based controllers, which use soil moisture sensors to manage when you irrigate. So we have that basic control technology we call smart controllers, but we can incorporate other types of sensors with this technology to help us better manage our landscape irrigation sensors. So we can incorporate items like rainfall shutoff sensors, and I'll talk briefly about those a little bit later. We also have more widely available flow sensor technologies that we can add to smart controllers. And the benefit of flow sensors is that we can then program our controllers to have a learned flow for each of our irrigation zones. So if we ever have a break in our irrigation system, we can be set up for notifications or to turn off irrigation when there's irregular flow events. So that can help us save water when something's wrong with our irrigation system. And then we're seeing other sensors out there. You can incorporate wind sensors, freeze sensors. Manufacturers are looking at other different technologies that we can incorporate with existing smart controllers to fine tune and improve their performance. When we talk about irrigation application technology, like I said, this is how we actually apply the water to the irrigation. So when our controller says it's time to irrigate, and it tells the valve to turn on, how are we going to actually apply that water to the landscape? And so current state of technology we see is we have drip irrigation. We haven't really seen a whole lot of changes in drip irrigation technology in the last 10 years. I believe we've seen better improvements in the manufacturing of drip products, which is good. So we know we have more consistently produced products that are going to do a more uniform application, and can operate under a wider range of operating scenarios. And then we look at irrigation sprinklers technology. We often see the term high efficiency nozzles used. That can mean a lot of different things when it comes to irrigation sprinklers, as far as what do we consider high efficiency. But we also have what are called multi-stream nozzles, or the newer term we're seeing used now is multi-stream, multi-trajectory nozzles. And the goal with these multi-stream nozzles, or these high efficiency nozzles, is to produce a more uniform water droplet size. And so if we can apply more uniform size water droplets through our sprinklers, then that can help improve the uniformity of application to our landscapes, where our turf looks better, we don't see as many dry spots occurring, and it helps reduce the problems like wind drift or just evaporation losses from applying that water through the air. And so we can kind of see here in this picture, on the right here, this is a high efficiency nozzle here, standard fixed nozzle, whereas down here at the bottom right, we call that a multi-stream, multi-trajectory nozzle that would actually rotate. And then we also see the incorporation of pressure regulation becoming a bigger part of landscape irrigation systems. And I'm going to talk more about pressure regulation in a little bit, but just to kind of break it down, why is it important? Well, most sprinklers are not designed to operate at high pressure. When you operate operate a sprinkler at too high of a pressure, you get very fine water droplets occurring. You kind of see here in this bottom left picture that kind of a misting effect, and that's not good for the uniformity of the system. Our water isn't thrown as far, it's not applied evenly, and so we could end up with stressed parts of our landscape. And we have high pressure because cities like to have high pressure. That's how they deliver water from the source to the furthest customer in their system. So they like to have high pressure, but our irrigation systems do not need the amount of pressure that we often have available. So by incorporating pressure regulation in our irrigation systems, we can increase the performance quite a bit. So how can we identify efficient technologies in the marketplace for us to use? Well, the easiest way to identify an efficient technology is by referencing the EPA WaterSense program. The EPA WaterSense program has been labeling irrigation products for about 10 years now, and those products have to undergo testing and certification to be certified as water efficient. And if you're not familiar with the EPA WaterSense program, I would encourage you to go to their website and do some reading. There's lots of good information, not just for landscape irrigation, but in-home water savings as well. So if you're not familiar with what WaterSense is, it's a program of the U.S. EPA, Environmental Protection Agency, and the purpose of it is to help consumers make smart water choices that help them save money and maintain high environmental standards without compromising the performance of these products. And so when WaterSense labels products, they're saying that these products are at least 20% more efficient than standard products you may find on the shelf. So this program has been around for a very long time. You may recall, like in the early days of the WaterSense program, that's when we saw the low flow toilets become very popular across the state. Those were one of the very first products to be labeled as WaterSense. But they expanded into other products, sink fixtures, urinals, shower heads, rinse valves in the home. But the EPA WaterSense program also looks at outdoor water savings and have identified certain irrigation products that can help consumers. So just some little background. in the very first product that EPA WaterSense labeled back in 2012 was weather-based smart irrigation controllers. And so we often refer to these as ET controllers because they use either real-time or ET principles as a basis for calculating how much water plants need. And then a few years later, in 2017, they started labeling spray irrigation sprinkler bodies that have built-in pressure regulation. And then recently in 2021, they started having a label program for soil moisture-based irrigation controllers. And then here in the last year, they've released a notice of intent that they would like to come out with a label for spray sprinkler nozzles, or what they call multi-stream, multi-trajectory nozzles. So I mentioned those high efficiency multi-stream nozzles earlier. They've released a notice of intent, and so they're doing their research, figuring out how they're going to test these products and what performance standards they have to meet to get the label if they move forward. So that's something to look forward to here in the next year or two. So weather-based irrigation controllers, these have been around for quite a while now. One of the earliest smart controllers came about in the early 2000s. And so this is not necessarily a new technology. It's about 20 years old, where we see off-the-shelf products being available for both residential and commercial applications. And so WaterSense program, if you're curious, I'm not going to go to a whole lot of detail of it, but to get the WaterSense label, a product has to undergo a 30-day testing period where it has to have a certain adequacy and not produce any excess. And so currently, these numbers are up to date as of July of this year. There are 962 weather-based smart irrigation controllers that have received the WaterSense label. And so that's a pretty big list of smart controllers. But in reality, this list really isn't that long. These 900 smart controllers that have the WaterSense label actually only come from 21 manufacturers. And so when you're looking at manufacturers, either at the local irrigation store, or you're going to a box store like Home Depot or Lowe's or some other garden center that may sell irrigation supplies, you can look to see, do they have a product, or do they carry products from manufacturers that are WaterSense labeled? And so, like I said, these are the 21 manufacturers who all have a product that has been labeled. And so you can look up online specifics about it, but if they have that product label, then they'll have that little sticker on the box saying that it does have the WaterSense label. So if you're familiar with any of these brands and manufacturers at your local irrigation supplier, then you should be able to find a WaterSense labeled product in their inventory. Like I said, that in 2017, the EPA started labeling spray sprinkler bodies, and these are products that have built-in pressure regulation. And so they test these sprinklers starting at 30 psi up to 70 psi to make sure they can adequately regulate pressure and maintain a nominal performance in the landscape. And so currently, there's actually 572 models of spray sprinkler bodies that have the WaterSense label. And again, this number's it's a big number, and it can be a bit overwhelming, but it actually only comes from 10 manufacturers who produce this. And of those 572, we'll see different models or series. So one manufacturer can have definitely multiple models of sprinklers in their catalog based on how those sprinklers operate. For example, if they have a sprinkler that pops up 2 inches, 4 inches, 6 inches, 8 inches, or 10 inches tall, those all count as individual models, even though they might have the same pressure regulator built inside of them. So we can see of those 10 manufacturers, most of those manufacturers have a pretty big product line of different types of pop-up heads that have built-in pressure regulation for many different configurations, whether you need one to pop up 4 inches or need one to pop up 12 inches based on your landscape needs. They have multiple models in their catalog to help you out there. And again, you see almost all of the manufacturers we see listed here. Most of these are large enough manufacturers. They also had smart controllers on their inventory as well. And then most recently, we saw in 2021 the label come out for soil moisture based irrigation controllers. So these are the smart controllers that use soil moisture sensors in the landscape. And so background on this is, product labeling is they put these sensors in the same soil, but the soil has different levels of moisture content. And so they monitor to make sure that these sensors can recognize different thresholds of moisture level in the soil, so that when you go to set your soil moisture based sensor, it can recognize that the soil is wet or dry or in between. And so this is one of the newer labels to come out. And so not many manufacturers have undergone the testing program for this yet, but currently we have 2 manufacturers who have received the label for their product. That is the Baseline company here on the left, as well as the Aerometer company on the right. And so 2 very different technologies that are both very good, very accurate, can help you manage your system, especially during the wet parts of the season. It keeps a good eye on your soil conditions, that if it rains and you have plenty of moisture from recent rainfall events, it can delay irrigation for quite a while until the soil dries out, allowing you to irrigate again. And like I said, they've released a notice of intent for multi-stream, multi-trajectory sprinkler nozzles. And so we see these used in lots of applications. These have been around for a while too. And we see these very highly promoted as the top tier of sprinkler irrigation efficiency. And that's because they do produce more uniform water droplet sizes. And studies out west, particularly a study out in Nevada, showed that by replacing conventional rotors with multi-stream, multi-trajectory rotary nozzles, they were able to increase uniformity by upwards of 20%. Another benefit of these nozzles is that they have a lower operating pressure requirement. So they typically only require about 40 psi to operate, so that's good. So if you have a system that doesn't have a lot of pressure in some cases, they're easy to incorporate into your existing system. These nozzles are also designed to use less water per nozzle. So that decreased flow rate has multiple benefits. It allows you to put more sprinklers per zone, so you can irrigate larger areas. The fact that you're applying water at lower rates reduces the potential for runoff or erosion concerns. However, that decreased flow rate does mean less water is being applied, so you often have to increase your run time. You have to run your system a little bit longer each day to put out the amount of water you need in your landscape. So if there was a disadvantage, which I don't consider it a big disadvantage, you have to just have a little bit longer run time to put out the amount of water you need in your landscape. And so you can see here some examples of those multi-stream, multi-trajectory nozzles in the field. Rain and soil moisture sensors, these are not labeled by the EPA. However, these are required to be used according to state landscape irrigation regulations. Back in 2009, well, go back before 2009, legislative session, House Bill 1656, I believe it was, is when we saw some updates to the TCQ landscape irrigation rules. And it said that after January 1st, 2009, all landscape irrigation systems that were installed had to have either a rain sensor or a soil moisture sensor attached to them. And so most often we see rain sensors incorporated into the landscape because those typically tend to be the less expensive option for the consumer. But rain sensors, they help us prevent the irrigation controller from turning on when it's raining. And so what you have to understand is that with rain sensors, they don't actually measure the amount of rainfall that occurs, they detect rainfall. And so you can set these sensors for different thresholds. So you can say it has to detect at least maybe a 1/4 inch or a 1/2 inch of rainfall before it turns off the irrigation controller. But it doesn't know how much rain occurs after that. So if you get a 1 inch rainfall event, it doesn't know you actually got 1 inch of rain. if you only had it set to 1/4 of an inch. So they just detect a minimum rainfall has been met and turn off the irrigation system so you're not irrigating during the rain or you're not irrigating soon after it rains. Compared to soil moisture sensors, which actually measure how much moisture is in the soil, and then based on your threshold, will not allow the irrigation to occur until the soil is dried out to a particular level. And this is the way a soil moisture sensor works is very similar to, like, right now how you may be operating your home AC thermostat. You have a certain temperature point, and when it gets too hot, what happens? Your AC turns on. And so whenever it cools off, then it turns the AC off. And so that's the same way a soil moisture sensor works, is that you set how wet you want your soil to be, and as long as it's that wet, it's not going to allow irrigation to turn on. But once it dries out, then it allows the irrigation controller to turn on until the soil becomes wet enough that the sensor then turns off and doesn't allow any other irrigations. But the good thing is that, you know, these are both very good technologies that can be implemented, and you can even use these together in most cases if you want to use them both on an irrigation controller. And these can be used with almost any existing irrigation controller on the market as an add-on device. Drip irrigation. Like I said, there's not a lot to talk about with drip irrigation. We haven't seen a lot of changes in using drip, but we've seen improvements in manufacturing, the way the manufacturers are making the products to make them more durable and operate under wider ranges. And so where we used to consider drip to be very sensitive to high pressure operation, most drip products now have some type of pressure compensating ability now from the major manufacturers to where we can operate drip products at 40, 50 PSI, whereas earlier drip products were more sensitive to high pressure where you would damage the product. And so we like to use drip. It allows us to have a higher application efficiency. And so when we compare drip to sprinklers, we often refer to the application efficiency. And that's because with sprinklers, you have to throw that water in the air, and we run the risk of some of that water evaporating in the air or maybe the wind blowing it away. So the water that leaves our sprinkler may not always all hit the soil where it's supposed to. Whereas with drip, we're applying that water either at the surface or either in the soil itself. So we often don't have those losses that we could have with wind or direct evaporation when we use drip products. So we can achieve a lot of water savings that way. But we see drip most often used in our bedded areas where it can be installed below ground or on top of the ground and even covered with mulch to reduce evaporation. But overall, we look at drip products. We really have two types of drip products available. We have what we call drip emitters or point source emitters, where we see on the left here, these products are often used in bedded areas to irrigate flowers, shrubs, or you can easily irrigate potted plants, versus drip tubing that has the emitter built inside of it. And we can use these in almost any application, both in flower bed applications or becoming more popular use in turf grass applications. So, like I said, we've been doing some testing and product evaluation of smart irrigation technology in our laboratory for quite a while. Our laboratory is actually one of the laboratories that works with the EPA WaterSense program to evaluate testing protocols as well as conduct official testing for products to be certified and get the WaterSense label. So we do a lot of different testing, and so I want to just hit on some of our testing we've done in the last few years. And one of the things I think you find really interesting is some of our work with pressure regulated sprinklers. And so you can see here's one of our test setups here in our laboratory where we can control the pressure and monitor how sprinklers perform. And here's an example of some laboratory data. And so we have here multiple models of sprinklers here that some have pressure regulation and some do not. And I don't know if you can see my mouse here or not, but we can see here at the top here, we have two models of sprinklers here that do not have built-in pressure regulation versus some models down here that do. And so we can see here these models that do not have pressure regulation, what happens is on the bottom here as we move from 30 psi and we increase the operating pressure to upwards of 70 psi, what actually happens is our sprinkler nozzle will apply more water, more pressure, more velocity, more flow. And so we can see here by operating our sprinkler at 70 psi, a standard 1.5 gallon per minute nozzle will actually almost apply 2.5 gallons per minute per nozzle. So we can see almost a full gallon per minute more per sprinkler by operating at a higher pressure. And so that can have major effects on the performance of the system. If you don't have a lot of water to start with, that can affect the hydraulics and performance of your system to where you may not have enough water for all your sprinklers to have a uniform application. And so we want to have our sprinklers operate at the pressure and the flow rate the manufacturer has designed. And so we've done some work in the laboratory, you can see there, but we've also done some really good work in the field retrofitting existing systems. And I want to highlight one case study we did with some rotors, looking at conventional rotors versus rotors that had built-in pressure regulation. And so we see here, this is in a commercial apartment complex in College Station we did this at. And here's our sprinklers. And we can observe signs of high pressure occurring with these sprinklers because we can see some misting occurring. And so that's always a visual indicator of high pressures when you see that misting occurring at the heads. So we went out, we did a catch can audit on the system beforehand and measured the performance of the system. And then we removed the existing sprinklers and replaced them with sprinklers that have built-in pressure regulation, same nozzles, but just incorporating pressure regulation. And we can see here when that system turns on now, we have very clean water streams coming out. We don't see a whole lot of excess misting occurring in the operation of that system. So let's just look at what we found out about this study here, this implementation. So we did 2 tests before and 2 tests after the retrofit, and these were all operating at high pressure. And so let's look at the results. So the first thing we always look at is what's the precipitation rate? So how much water is the sprinkler applying to the landscape? Call it the precipitation rate. And what we find here is, surprisingly, we didn't see a significant change in the precipitation rate. We can see here if we average the results from the first 2 tests, we're looking at about 0.25 inches per hour. And we average the results from the second test after the retrofit. We can see the average is about 0.23. So the rate at which we're catching water really didn't change. We're catching the same amount of water, but when we look at the uniformity values, what we saw is a large increase in the uniformity between our catch devices. So we're applying water at the same rate, but we're applying it more uniformly to the landscape area. And we were able to document a 27% increase in uniformity by incorporating pressure regulation. We also recorded water usage during this test. And like I showed you with the lab data, when you increase your pressure, your flow rate also increases. So we can see here when we did the test before, we were using over 9.5 gallons per minute per test. After we incorporate the pressure regulation, we ran it for the same amount of time, but the sprinklers only used about 7 gallons per minute. So we were actually able to decrease our water usage by 23%. So putting this all together, a 23% decrease in water usage, but a 27% increase in uniformity is a significant increase in the overall efficiency of that irrigation system by just incorporating simple things like pressure regulation. We've also had a long time program of evaluating smart irrigation controllers. So we've been able to document the evolution of smart controllers from the very first models the manufacturers came out with to what we see available today. And so what we see being most popular today is the availability of Wi-Fi based landscape irrigation controllers. And so these are controllers that can access online weather data sources to help manage, do you need to irrigate? And if so, how much irrigation do you need? Now, we still have some manufacturers that follow more of a conventional approach to smart controllers that will incorporate on-site weather sensors. So we can see here on the right some products that have to have a sensor attached to it to measure the weather outside. We still see those available, but we're seeing kind of a shift now where in the early 2000s, everything had a sensor on it. Now we're starting to see manufacturers tie into all these sources of weather data we have available and not have to have a sensor actually on the controller. So this is an ongoing program. We test these products continuously. So I want to kind of just highlight last year's performance. The study is going on right now. So if I come back next year, you'll be able to see this year's data. But look at a highlight of what we saw last year. So we programmed these controllers to irrigate different types of landscapes. So we program them for flowers, turf grass, ground cover, small shrubs, and large shrubs, okay? And so we enter in all the details that are needed to program a smart controller, and we evaluate how much water each controller used per year and over each season. And that's how I'm going to highlight here briefly is how each controller looked over the seasons. And so here, if we look here at the spring season of last year, I'm going to focus here on where it says 2 and 3. Those were the two zones that we programmed our smart controller to irrigate turf grass. So everybody always wants to have good turf grass. And we can see here how much water did these controllers apply to their turf grass zones. And we can see here, if we just look at the turf grass area, that zone 2 and zone 3, not all these controllers are performing the exact same. Some are using more water, some are using less water. And so our goal would be to have the controllers pretty close to the dotted line. That's our calculations there as far as how much we interpreted that the landscape needed. So the closer they are to the dotted line, the better job they're doing. So here's a good visual representation to kind of break it down for you. But if you're a number person like I am, I have the numbers too. So you can see here each manufacturer in each zone. So if you look at last spring, we can see which controllers did a pretty good job. And so what I've done is I've highlighted here in yellow which controllers were within 20% of our calculation. So if they're within 20%, we think they're doing a pretty good job. But when you look at these numbers here, you can see some controllers didn't have any within 20%. And our best performing controller in the spring only had 5 out of the 6 stations within 20%. So nothing was perfect, but we saw some controllers did a better job than others in the spring. Now we go into the summer month. You can see here some of these controllers are getting closer to our target line, but we can still see some kind of being a bit excessive here. I like this graph because you can kind of see how high above the target line were some products. We prefer the controller to be close to the dotted line, maybe a little bit under it if we're really being conscious about conservation, but we want to avoid being excessive in our irrigation. So again, we look at the hard numbers here, and we can see, the controllers did, I think, a better job in the summer months, and that's what we would want to see probably. That's the time when we see our landscapes being most stressed and water supplies being stressed out as well. We want them to be doing a good job in the summer months. So you can see here multiple controllers within 4 or 5 stations of our 4 to 5 stations out of the 6 doing a pretty good job here. Some controllers still struggle with how much water they're putting out. And then we go to the fall period here. And we kind of see, looking at some of these zones here, the controllers, start to perform closer to each other if that's important. You look at this, but we look at the numbers here, and we can see here they didn't really do a good job by our standards in the fall. They did a good job in zone 1, that was our flowers, but not so well in the turf grass areas. So a wide range in performance. So if we kind of break down, seasonally, how do these controllers look? Excuse me. We can see, here we rank the controllers by which was closest to our calculations to furthest from our calculations. And so we can see here, if we look at the manufacturers in the spring, the Ratio was number 1, and the Sprinkle controller was number 2, and the Toro was number 3. In the summer months, we saw a shift. The Orbit Beehive controller was number 1, the Sprinkle was 2, and the Ratio was 3. And then in the fall period, the Orbit Beehive was number 1, the Ratio was 2, and the Toro and the Ratio tied for second place. So you kind of average that out over the year. You can see there was obviously no number 1, but we can see which controllers were performing towards the top tier of performance, and which were performing at the lower end of our tier. And so this is interesting here because we can look here and see that, for example, the Ratio and the Beehive kind of tied here for the number 2 spot. But if we actually went back a year in 2021, we saw a completely different performance out of the smart controllers. And so the controllers that did a very good job back in 2021, they didn't perform as well in 2022. And part of that could be because if we go back and we compare the 2 years, 2021 was a wetter year. And we look at how much rainfall occurred year to year, and we know we had a wetter year versus a drier year between the 2 years. And so it'll be really interesting here once we get through this year, this fall, to take the numbers and compare to see, now that we have 3 years of data between these newer models of products, which has a better trend now. 2 is a start, but we really don't have enough data to point at what can handle year to year. So it'll be interesting to see here. Okay. So overall, no controller has achieved a consistent perfect performance yet. So I don't want it to sound like I'm not a fan of smart controllers. We see that some are definitely doing a very good job. Me personally, I'm striving for that perfect controller, and I hope that perfect controller exists, because manufacturers are always updating their software, making improvements. So these products perform a lot better than the products did 10, 15 years ago. So they're getting there. And I think they have lots of potential for water conservation, because when we look at the raw data, I didn't have time to go into all the bits and pieces of this, but we see that the controllers make adjustments throughout the seasons. When we go back and we look at rainfall, when it rains, the controllers are not irrigating as much. They are responding positively to rainfall events. And if we just compare most of these controllers to a standard controller, which you set a runtime and it has that same schedule year round, then the top half of these controllers are going to do a much better job than if you set it and forget it with your irrigation controller. But what I really like about this technology, especially the Wi-Fi technology, is the ability to manage it from your phone via the manufacturer's app. So even if you aren't quite sold on the automatic irrigation scheduling ability of it, being able to turn it on and off from your phone is a very valuable tool. Because I don't want to pick on homeowners, but I know whenever I go out to work on irrigation systems, it seems like half the time whenever I go visit a property, I go to the garage and I have to move either a stack of Christmas decorations or something away from the wall to find the irrigation controller. And so that tells me that if there's something blocking the controller, they're probably not making many adjustments to their scheduling. And so we should be adjusting our schedules throughout the year so that we aren't over irrigating or irrigating too often. And so by having that at your phone, everybody's on their phone these days. It doesn't take but a few minutes to just pull up the app and say, you know what, it rained this week. I'm going to turn my controller off. Or you know what, my lawn looks a little stressed. Maybe I'm going to increase my run times for a few minutes this week. So that flexibility of a mobile device is a very valuable tool. And so finally here, what I want to end the presentation with today is I want to talk about Water My Yard. And so we have lots of technologies out there to help us with irrigation. We talked about control technologies and application technologies, but we see that nothing's perfect yet, especially when it comes to the control technologies. And so what do we have available to help us manage how much irrigation we need with our landscape? And so the Water My Yard program is a great resource for the most novice home landscape manager to determine, hey, do I need to irrigate this week, and how much should I irrigate? So this program, as Blake said, it's offered between Extension and your local water utility. And so the program requires your city or your utility to sponsor each service area. So they help cover the cost so that it's a free watering recommendation to you, the end user. Okay, my computer's froze here. I can't go to the next slide. Blake, can you hear me?
Yes.
Okay, so you can hear me still, but my screen is frozen.
Are you able to exit out of full screen?
I'm trying to. It's just showing this main screen here. Give me a second. Let me try Control Alt Delete maybe. Let me try something here. I'll come right back.
Okay.
Hmm.
While Charles is continuing to work on that, I will mention that, yeah, since Water My Yard is dependent on a local city or utility, like Upper Trinity, to sponsor the program for their area. Some areas don't have water my yard. So thinking of like the city of Dallas and Tarrant County, those do not have water my yard. But they do have a similar type program called Water is Awesome. And they have weekly watering advice from that as well. And I will put that link in the chat. So if you're not in Denton County or Collin County or the city of Irving, this is another website you could use to get weekly lawn watering recommendations. All right, so it looks like Charles had to leave, but he'll come back as soon as he can. But yeah, while we're waiting on him, the Water My Yard program is we get the local weather data from weather stations that the sponsor purchases and maintains. So here at Upper Trinity, we have 3 weather stations that connect to Texas A&M, send them the weather data every day that they utilize for the Water My Yard program. There's one in Louisville, one in Argyle, and one up in Providence Village along 380, just east of Denton. So that's where the Denton County recommendations come from. But then to our folks to the east and like Prosper, McKinney, Frisco, Plano area, and further, the North Texas Municipal Water District has several weather stations that supports that area as well. So it's a free program. If you're in a city that is supported by it, then you can utilize it no matter who the sponsor is. But while we're waiting on them, if you have any questions about anything Charles has said, feel free to put those in the chat, and maybe we can talk about those here real quick. All right, while Charles gets back up and going, I'll address Jason's comment about being like the Arizonans to stop building massive housing communities with acres and acres of grass. Imagine the amount of water we could save running artificial turf or desert style landscapes with local plant life only. And yeah, I mean, I agree we need to cut back on the amount of grass that we have. But there has been studies like out of city of Austin when they took out people's turf grass and put in more rock type features and desert plants, and actually found that it increased that home's air conditioning usage, and so their energy bill went up because the rocks and those hardscapes actually continue to radiate heat all night long, as opposed to the turf grass, which has a cooling effect around the house. So that's, that's the only thing about doing what we call xeriscaping is you actually have result in higher energy use because yeah, we want to cut back on our water usage, but we're not like Arizona in that we're not in a desert. So I definitely native plants. There are many uh, shrubs and ground covers that um, we can use to um, cut down on our water usage, but we don't typically recommend doing a lot of rocks and things like that around the house.
Okay, am I back, Blake? Can you see me now?
Yep, we can hear you. We can see you.
Okay.
See your presentation.
All right, let me get back to that slide here, and hopefully it doesn't do anything odd again. I apologize for that. Okay, so I'll pick back up here. Again, sorry for the delay. So how much water does your lawn need? And so why do we have water in my yard, and how does it work? We have to understand how much water plants need. And so, some homeowners have a hard time understanding is that the water requirements can vary significantly for plants throughout the year. If we look at just a normal cycle here in Texas, turf grass lawns go dormant in the winter, begin to green up in the spring, and this can vary depending on where you're located at. Here in North Texas, we didn't see a lot of good green up of our turf grasses till late April, given the late freezes we had. And then our water use will peak in the summer. And historically here in Texas, what we see is water requirements will peak around the last 2 weeks of July to the first 2 weeks of August. So we're kind of right now at that peak period to where we're going to be our highest water requirements of the year. But then slowly what we should start to observe is water requirements will slowly start to decline into the fall until they go dormant again in the winter. And the way we track water use of plants is we calculate evapotranspiration rates. And so what is evapotranspiration? I've said ET a couple of times. It's a measurement of how much water has evaporated from the soil surface, as well as how much water has been transpired by the plant. And so it's difficult to measure this directly. You have to have very specialized equipment permanently installed in the ground to measure it directly, but there's been enough research on this that you can calculate this if you know enough information about the local climate. And in particular, if you know your daily temperatures, humidity, solar radiation, and wind, we can calculate daily evapotranspiration rates. And so we use what we refer to as ET weather stations. These are weather stations that are specifically installed in turf landscape areas to monitor the climatic conditions as they would for a standard landscape. And so we see here as an example of an ET weather station. These are scientific weather station, research grade weather stations, so they're very high quality. And we can see here it's installed in a nice open turf grass area. So it's measuring the environment as it relates to landscape water use. We don't want to use weather stations that are on top of buildings or in concreted areas where they're going to get irregular readings, maybe due to a heat island effect. We wanted to know what would the environment be like around a landscape plant. So we can calculate those ET rates using weather data. The next part is where irrigation can get a bit more challenging is, the ET can be the easy part, but then how do you determine how long to run your irrigation system? And so one of the challenges we have is that we look at these catalogs of manufacturers' products. All these different sprinklers apply water at different rates based on the sprinkler type, the spacing between sprinklers, the operating pressure of the sprinklers, and then we compare that between different manufacturers. There's no standard as far as how much water sprinklers have to use. And so every sprinkler uses a different amount of water. And so what may be 10 minutes of irrigation for one type of device may require 30 minutes of irrigation for another type of sprinkler to apply the same amount of water. And so the range that we can see can vary from as little as 0.4 of an inch per hour up to over 1.5 inches per hour as far as how much water a sprinkler will apply to the landscape. So it's hard to come up with a generic runtime because there's so many different designs and configurations of sprinkler irrigation systems that you really need to know what your precip rate is. So the precip rate can be challenging. So when it comes to irrigation and conserving water, we want to turn on our system to only apply the amount of water our plants need. If we don't follow any prescription as far as how much, taking into account ET or our precipitation rate of our sprinklers, we could end up having excess water costs by over irrigating the landscape. We could affect the quality of our plants, whereas too little of water can show drought stress. Over irrigating a plant can also decrease its quality. And this can also lead to additional waste and runoff problems downstream. So the way we would approach water conservation in this aspect is to adjust our run times throughout the year to only apply the amount of water our plants need, and when possible, turn off our irrigation system during the rainy period of the year so we don't have to irrigate at all during those times. So that's where Water My Yard comes in. It does all the background for the user so that all they have to do then is get their weekly watering recommendation to tell them how many minutes per day they need and how many days per week they should water. And it does this by taking into account the local ET and weather data, and then you select your sprinkler type to set the precip rate. So if you're not familiar with Water My Yard, you've never used it before, it takes less than 5 minutes to sign up, and it's just 4 basic steps. All you have to do is either go to the Water My Yard website, or you can download the Water My Yard app free on your your smart devices. So it's available in both the Apple and Android stores. Or if you just want to go to the website and sign up directly there and not worry about putting on your phone or your iPad, you can do that as well. So you download the app, go to the website. Here's what the website looks like. You can follow the Get Started button there or scroll down, and it's going to ask you to enter your location. And so by entering your address, either your full address, you can just put your city or your zip code as well. What it's going to do is it's going to check for 2 things. It's going to, 1, see, are you in a sponsored service area? So if you're a part of this and you're within the Upper Trinity Regional Water District's service area, you're in a service area of the Water My Yard program too. And then it's also going to look to see what is your closest weather data source. So some of our service areas like Blake at Upper Trinity Regional Water District, they have 3 weather stations in their service area. So which weather station is closest to your location? We're going to find the closest ET data and the closest rainfall data. So we can see here, got a little screen capture of the app, what it would look like. And here's what it looks like on the website. Enter your location. So you enter your location, it verifies you're in the service area, and then you have to finish creating your account, entering your email. You can also sign up for text messages, or if you're using the app, you can just get the app notification. So it'll give you a little push notification that'll pop up on your phone saying, hey, you need to irrigate this week or you don't need to irrigate this week. You can also choose which day of the week you want to receive your watering notifications. And so you can see here, picture what that looks like on the website versus the app. And then we get to step 4, and that's often the most difficult step of all, is you have to enter your precipitation rate. So if you don't know, but unfortunately we know a lot of older systems, if you buy a newer irrigation system today, you probably have your precipitation rate written on the irrigation design you purchased. But if you don't have access to your irrigation design that you had installed, we have some tools here to help you determine what is your precipitation rate. And so we call it the precipitation rate wizard. And so you come in here, you name your zone. So you either give it a number or you want to call it your front yard zone. You can click on this green button here that says the precip rate wizard. And you can follow these tools here to select what kind of sprinkler do you have. And what we've done is we've built in the manufacturer's catalog into the program. And so by selecting your sprinkler type and your manufacturer, your spacing, we can look up what your precipitation rate is and use that to calculate your watering recommendation. And so we can see here, I have his profile set up here with, and it tells me for when was this recommendation produced. My weather station, I have zone 1, zone 2. Each of these zones has a different precipitation rate. And you can see here, it tells me that no watering is needed because it shows here I have some 0.7 inches of rainfall occurred. However, what if you have no rainfall like lately here? I have examples here of an email I got. Here we can see this one shows that I need a 1/4 inch of water this week, or based on my irrigation system, 1 watering for 9 minutes will meet that need. If you signed up for the text messages, you can see here, here's a little text message history I got from Water My Yard. So you can see here 3 weeks in a row, it told me that no watering was needed. And then it tells me here that, then for these other 3 weeks that I should irrigate about 23 minutes a day for my zone. So it takes into account the changing conditions each week to determine, do you need to irrigate based on the local rainfall? Did any of the rainfall from last week carry over to this week? Or has it dried out to where you need to run your system based on the type of sprinkler you selected? And what I have here is a highlight of some Water My Yard data from the last 2 years, just to compare. We can see that in 2021, this is using the Louisville weather station. This is actually at the headquarters where Blake is based out of. You can see that it calculated in 2021, we only had 19 weeks where we needed to irrigate. And in 2021, we actually peaked in the middle of June at about 0.7 inches of water per week. But we can see here there was lots of weeks where there was no irrigation needed throughout the main growing season. But we compare that to last summer, and wrong direction. We compare that to last summer, and we can see that last summer we had to irrigate 25 weeks. So it was much drier in June, July, and early August. And you can see there that it actually peaked in the middle of July at about 1 inch per week. And so year to year, it varies quite a bit. So if you had the same schedule back-to-back years, you would see 2 very different watering needs occurring. Not as much irrigation needed in 2021, more irrigation needed last year compared to that in 2022. And then we're seeing this year being a higher need year, much drier. Right now, this week, our water calculation showed about 0.9 inches of water per week for North Texas. So we aren't at, we might be towards the end of the 1 inch mark here. We'll have to see if we continue to have these heat advisories where it's hot and dry. But we're peaking right now about 0.9 inches of water for this area here in North Texas. So hopefully they're saying maybe in the next 2 to 3 weeks that this high pressure is going to move away, and maybe that'll bring some rainfall relief into things. So cross your fingers, and I guess we'll see what happens. But we can see here the data, how much water you could have saved if you were following Water My Yard back-to-back years. You don't need to irrigate when it rains, so that's water savings for you and rainfall for your yard. And so as I kind of come to closure here, I know I'm a little bit over time here, unfortunately. I just want to point out we have some great resources on our website. We came out with 2 really good publications this past year. One was on irrigation cycle and soak and how to prevent runoff. You can find these on our website, or if you go to the AgriLife bookstore website, which is agrilifelearn.tanu.edu. These are free downloads. They don't cost anything. We have this quick guide here, as well as a much more elaborate or detailed publication that goes into more details about managing your irrigation system to prevent runoff. And we have an irrigation publication that came out on irrigation efficiency. And this talks a lot about pressure regulation and managing how you apply water to your landscape irrigation system. So great resources that if you have concerns about your irrigation system right now and you want to be at peak management right now, I'll go to the website and download these to get you through this this dry period when we're at our peak water usage right now. With that, I'll open it up to any questions I might have missed here. I can't see the chat bar, Blake, but if there's a question, you can read it off to me and I'll try to answer it.
Yeah, we got one from Jill on how to optimize for partially shaded areas that probably don't need as much water with the Water My Yard recommendations.
Okay. If you use the Water My Yard app, I didn't have a screen capture of this, but it's a great question, by the way. And it brings up this point here on the Water My Yard app on your phone or smart device. We have 2 additional tools. One tool is the adjust rainfall tool, which you probably aren't using a whole lot right now, but with the adjust rainfall tool, you can actually enter in your own measured rainfall in case you measured more or less rainfall than the local weather station to adjust your watering recommendation. But so that's one thing. But the second thing is we have a runtime adjustment tool. So if you want to achieve additional water savings, or you're seeing that you want to you have areas of your landscape that are more shaded, you could adjust your runtime by an additional 10% to reduce water usage. And this also, there's a plus 10% and a minus 10% button on there. And so I would use that minus 10% to reduce your water usage at that additional savings. If you observe that you have some hot spots in your yard, maybe that's getting some reflection off of a building or some windows that's drying out a little bit quicker, you can always hit the plus 10% and increase your run times a little bit to give your grass a little bit more. But that's a great tool there. If you know parts of your landscape are using a little bit less water because they're getting a little bit less, maybe they're getting more shade, that'll help you do that.